So what's interesting about Common Core is that certain topics are covered at different grade levels, and the assumption is that you remember them from prior grade levels. So in 8th grade, the only three-dimensional shapes that we study for volume and surface area are the shapes that have circle-like parts. All the other shapes, they assume you already know the formulas because you should have studied them in years past. Now, grant you in 7th grade, you should have studied three-dimensional shapes, even 6th grade, if my memory serves me correctly, because I taught 6th grade here for 6 years. There's three-dimensional shapes. Okay, so my question is, what three-dimensional shapes involve circles or circle-like shapes? So what's one, Rochelle? Sphere. Okay, Corey? Cylinder. And we got one more. Riley? A cone. Those are the only three that we're going to focus in on this week. We're going to talk about volume, and we're going to talk about surface area. Volume is actually the easier of the two, and that's what we're going to start with. So we're going to work with volumes. Oh, come on. And we're going to focus today on cylinders and cones. And in my anger at last period, I handed them out the wrong homework assignment, so they'll get more homework tomorrow. Yep, come on. Okay, so volume of cylinders and cones. So basically, our whole main gist that we want to get out of this is I'm going to give you formulas, and you got to know them, and you got to know which one to use when, and plug numbers in, and the worst that you're going to do is multiply with some decimals. You're going to have to square a number, and you're going to have to multiply with some decimals. Now, how I'm going to expect you to give me your answers is the way that I expect my geometry students to give the answers. When you, let me just ask this. What is something that is part of every formula that deals with anything that has a circle-like shape in it? Pete? Pi. Pi stands for a number, and that number is actually goes on forever. We can't multiply by forever, so we give what we call approximations. What's the most common approximation that you guys have used for pi? Mackenzie? 3.14. The problem is when I use 3.14, I now have an estimated answer, and so that's not an exact answer. In geometry, we're really needing exact answers. So in geometry class, to get an exact answer for anything that has a circle, we use pi as part of the answer. So what that means for you is that you have one less decimal to multiply by, right? Because 3.14 is not going to be part of your calculations. You're going to leave the answers in terms of pi. So when you get to the homework and it says round the answers to the nearest tenth, you're going to disregard that set of directions because that's with the assumption that you're using pi, an approximation for it, like 3.14. What's the fraction version of pi? Nope. 22/7. Okay, and every fireman knows that number because every fireman uses that number. Why would a fireman use pi in their job? Kenny?
A fireman would use pi in a chart.
In his job?
In his job because he uses it to find out where to point the water to take down the fire.
It wouldn't be where to point the water. I think the fire would probably give that away. Okay? But what does a fireman use that would have anything related to a circle? Mackenzie? A hose. Basically, what shape is a hose? A long cylinder. Okay? So when we're talking about amount of water coming out, we're talking about the volume of the water coming out. So they use 22/7 in their calculation of pi to help figure out which hose they need in order to get the right amount of volume based on the size of the fire. Okay, so believe it or not, math gets used on a daily basis in other people's lives. So let's focus in on cylinders and cones. So make sure that we understand the difference between them. Okay, I'm getting a headache for that, kid. So the two main parts that we're interested in, whether it is a cylinder or a cone, is an R and an H. Okay? Now, let's figure out what R means and what H means. So what does R stand for? Radius. So we need to know a radius, and what's the H stand for? Height. Height goes from the top of the shape to the bottom of the shape. It goes to the center of the bottom, and in the case of one of the shapes, it goes from the center of the top to the center of the bottom. The other shape has only a point at the top. Okay, which one is considered a cylinder? So the one that looks like a can. We come across cylinders every day. We come across this cylinder. Okay, and the guy on the right, he's the cone. Okay, so what do you notice that a cylinder has that a cone doesn't? What does a cylinder have that a cone doesn't? Mackenzie. Okay, so he has a flat top and a flat bottom. Okay, how would we describe the cone? What's his top? Yeah, he's got a point. I'm going to say pointy top, kind of like a witch's hat, right? And flat bottom. That's the big difference between a cylinder and a cone. Cylinder has a flat top, cone has a pointy top. Now, they are subgroups of shapes that you should have already studied. What do we call a three-dimensional shape with a flat top and flat bottom in general? Not one that has to have a circle as part of that flat top or flat bottom. That's not a square. Square is two-dimensional. This is a three-dimensional shape. Nope, that's a specific one of the shapes that we're talking about. You guys don't remember prism? Prism is a three-dimensional shape with a flat top and flat bottom that are congruent. That means same shape, same size. Okay? What do we call when it has a pointy top and a flat bottom in general? It's not called a prism. I'll give you a big hint. You studied these in 6th grade when you were studying ancient Egypt. Pyramids. So all pyramids have a flat bottom and a pointy top. Now, the reason why we have new names for a prism and a cone is because the definition of a prism deals with having sides and having lateral edges. And the problem with cones and cylinders is that they have rounded sides, so there's no edges that we can see. So we can't technically call them a prism and a pyramid because they don't have sides. So we have to call them a new name to deal with these curves. And so that's where the cylinder and the cone comes from. Okay, now, generically, for all prisms, doesn't matter what the shape is of the bottom, with the exception of a cylinder, the formula for the volume of a prism is capital B times H. Capital B stands for the area of the base. So whatever that base shape is, you can figure out its area, and then you multiply by the height. Height is always the same, from the top flat piece to the bottom flat piece. Now pyramids, you can see, if I tried to take this cone, and superimpose it in that cylinder, the cone is way smaller, right? It doesn't have the full edges out. And so to compensate, we're going to take this formula, BH, base area times height, and we're going to only have a fraction of it for the volume of our pyramid. That fraction is 1/3. Those numbers remain the same regardless of what the area of the base is. So when it comes to our cylinders and our cones, the only difference we do is that we plug in the area formula for a circle. How do we calculate the area of a circle? What's that formula? Okay, my little friend in the back wants to volunteer an answer. What's the answer?
You use pi.
Pi times what?
Pi times the diameter?
Not the diameter.
The radius.
The radius squared. So radius times a radius times pi. I think you were thinking actually more along the lines of circumference, which when we talk about surface area, that's what we got to get into. So how does our formula change? We just substitute in the formula for the area of the base. We put in a pi r squared. So honestly, you don't have to memorize two brand new formulas. You just know these two formulas, and you plug in the formula for the area of a circle, which is the base. So here are our two formulas. Volume for a cylinder. V equals pi r squared, that takes the b place, times the height. And then we have volume of the cone. And that's going to be, come on, 1/3, and then pi r squared h. That's it. So again, if you know the formula for the area of a circle, is always pi r squared, all you do is replace the area of the base, which is the circle, with pi r squared. Okay. Now we're going to see this pi r squared show up again when we talk about a sphere, which we'll do tomorrow. So one more thing before we do some examples. Because we're talking about a three-dimensional shape, what label does our answer get? Cubed. So all volumes are cubic units. Or you could write it this way: units, whatever the units are, feet, meters, inches, miles, and then exponent of 3. We need to make sure all the problems that you have tonight require you to add the labels at the end. Okay? So one thing we're not going to do is we're not going to replace pi with an approximation. We're going to leave pi as pi. So your job is to take the radius number, square it, multiply it by the height. In the cone, you're going to have to do one more thing. You're going to have to multiply that answer by 1/3. Okay? All right, so let's do some examples. So our directions are going to say find the volume. And then I'm going to add, this is our new part to the notes, or to the directions for homework, so you're going to disregard what the book says and you're going to do this. Leave answers in terms of pi. Okay, so that's going to be the nice things. You're not going to have to do as much work on these. Okay, so let's do first one. So usually what's going to happen is they're not going to tell you information, they're going to draw information. So they're going to give you a picture. And based on that picture, you're going to be able to figure out what shape that you're using, so which formula you would use. So we got this, and often you'll just see a number off to the side like this. Okay. So what shape is this? And what's the formula for the volume of a cylinder? Yeah, this one has no fraction. It's just pi r squared h. So what we need to do is identify the radius and the height from this drawing. What's the radius in this drawing? So this is your radius, is here. And what's your height? Okay. So notice what we're going to do. We're going to take that 5 centimeters and we're going to multiply it by 5 centimeters. So that's centimeters and centimeters. And then we're going to multiply that by 8.3 centimeters. So now we have centimeters, centimeters, centimeters. So we're always going to have 3 of the same label. So we plug numbers in and we solve. So we have pi 5 squared times 8.3. So we have 25, that's 5 squared. We're going to multiply that by 8.3, and then we're going to leave pi at the end. So off to the side, I multiply a 2-digit number times a 2-digit number. And while I'm multiplying, I disregard the decimal, and I just multiply as if it doesn't exist. So I get 15, I get 7, I get placeholder, I get 40, I get 16, and 4 is 20, and I get 2,075. But I had 1 digit after the decimal point, so my answer gets 1 digit after the decimal point. So I write 207.5. Now, I'm leaving pi as pi. Now I need to add the label. Pete, you're not taking notes. And so what's the label in this answer? What is it, cube? Centimeters. So we say cubic centimeters, and that's it. Okay? So that's pretty indicative of the problems you're going to do. But what if they throw you a little loop and they give you this one? Come on. Come on. I'm sorry, I'm having such a hard time with this pen today. Yeah, that's not going to work. Come on. All right, I'm going to draw this bigger because it's... fussing too much. That took only forever. So they tell me that, and they say, okay. So what's the problem with the 2 numbers that they gave me? Faith?
Well, they gave you the radius.
Yeah, they didn't give me the radius. What they gave me was diameter. That is not part of the formula. So what do I know is true about a radius and a diameter? What's the relationship between those two? Rochelle?
The radius is half
So what I'm going to do is figure out what half of the diameter is. Oops. And I get 3 inches. Now that I have that, and I have the height, 7.5 inches, then I can use my formula. And I get volume equals pi r squared h. So pi, 3 squared times 7.5. So 3 squared is 9, and then I have times 7.5, and then I have pi. So off to the side, I multiply 75 and 9. I don't worry about the decimals, and I get 45. I get 63 and 4 is 67. But there was 1 digit after the decimal point, so my answer also gets 1 digit after the decimal point. So I get 67.5. Pi is still part of the answer, and then I'm going to write cubic inches. Okay? So let's try a cone. So again, the math isn't that bad. And let me find a good example here. So on the third one, let's draw a cone a different way. If I tell you that this is 4 feet, and then this is 5 feet. Okay. And because we know it's a cone, we now have to shift our formula. So what's the formula for the volume of a cone? Let's go back. That's the weird part, is we have to put in the 1/3. So we plug in our numbers, and we have 1/3 pi, 4 squared, times 5. So 4 squared is 16, times 5, times 1/3 pi. Now, can 3 divide into either of those numbers? No. So I'm going to end up with an answer that's a fraction. That's okay. So I'm going to multiply the 16 times the 5, which gives me 80 thirds pi, and then the label. What would the label be? Cubic feet. Okay. So a lot of times what happens because of that 1/3, you end up with a fractional looking answer. All right, let's do one more. Notice the math isn't that bad, is it? Last one. Let's do... No, usually the shape is given to you. But I just want you to get used to, they like to do funny things with cones in particular. So, I tell you this whole thing is 12 inches. And this is 13 inches. So again, because it's a cone, we know what the volume is, but what's strange that they give us again in this problem? They give us diameter again. So the diameter is the 12 inches. I need to figure out radius, which is half of a diameter. So I get half of 12 inches equals 6 inches. And then I'm going to put that together with the height, which is 13. Now because this is a cone again, it's going to be 1/3 6 squared times the 13. And then we get pi. I'm just going to stick them at the end there. So then I get 1/3 6 squared is 36 times 13 pi. Now can 3 go into either of those numbers? Yeah, it actually can. So we're going to simplify. 3 can go into itself once and into 36 how many times? How many? 12. So I'm left with 12 times 13. So off to the side, I'm going to just multiply 12 and 13. And we get 6, 2, placeholder, 3, 1, 6, 5, 1. And I get 156 pi. And now I need to add the label. What label would I get? Cubic inches.